Hi, my name is Alexandra Lopez. Today we're going to be talking about X-rays and the different ways that they interact with matter. Every time we perform an X-ray, the beams that enter our bodies react in a different way. It is very important that we understand each interaction so that we can help minimize the risk to the patients and us as radiologic technologists. There are 5 different ways that X-rays interact with matter. The first one is called photoelectric absorption. The second one is called Compton. The third one is coherent. The fourth one is pair production. And the last one we're going to talk about is photodisintegration. The first interaction we're going to be talking about today is photoelectric absorption. During photoelectric absorption, an X-ray photon hits an electron on the inner shell. This inner shell electron is now ejected out of the shell and turns into a photoelectron. Now that there's a missing electron in the inner shell, the outer shell electrons begin to move forward, replacing any missing electrons. This is called the cascade effect. The cascade effect causes secondary radiation. The next interaction we're going to be talking about is Compton scattering. Unlike the low energy photons that hit the inner shell electron during photoelectric absorption, during Compton scattering, a high energy photon hits an outer shell electron. This outer shell electron now releases out and is turned into a recoil or Compton electron. Scatter is then produced. Scatter is harmful to everybody in the room other than the patient. However, during Compton scattering, fog is produced because of this scatter, and fog affects the quality of the X-ray images.
Hello, my name is Rogelio Lizarraga, and I'll be explaining the 2 different types of coherent scatterings. The first coherent scattering is Rayleigh scattering. In Rayleigh scattering, the initial X-ray photon interacts with the entire atom and causes it to vibrate. The vibration then causes the atom to release an X-ray photon of the same wavelength as the first one. Since the wavelength is the same as in the first X-ray photon, the energy does not change. The initial X-ray photon is approximately 10 keV or lower. The next type of coherent scattering we're going to be talking about today is Thomson scattering. Thomson scattering differs from Rayleigh scattering because in Thomson scattering, the initial X-ray photon interacts with just one electron, causing it to release an X-ray photon of the same wavelength as the initial X-ray photon. In Rayleigh scattering, the X-ray photon interacts with the entire atom, so that makes Thomson different because it only interacts with one electron. The exiting electron is the same wavelength, so the energy would still be the same as the entering. And just like in Rayleigh, Thomson only occurs with 10 keV, or less.
The next interaction we're going to be talking about only occurs during nuclear medicine. Paired production. Paired production happens when a very high energy photon hits the nucleus at 1.02 MeVs. Once it hits the nucleus, 2 electrons are ejected out of the nucleus. One is negative and one is positive, also called negatron and positron. These two are going to be split up into 0.51 MeVs. The negatron is going to be absorbed by a nearby atom. The positron is going to interact with another electron and quickly disappear. The process of energy turning into matter and converting back into energy is called annihilation. Annihilation only occurs in paired production. The next interaction we're going to be talking about is photodisintegration. Photodisintegration occurs when a very high energy photon hits the nucleus at 10 MeVs or greater. Once it hits the nucleus absorbs it, causing it to become excited. The excited nucleus then emits nuclear fragments. This kind of interaction does not occur in diagnostic imaging because the energy levels are too high.
And finally, the last subject we're going to touch upon today is attenuation. Attenuation is when an X-ray photon passes through matter and loses energy. Although some photons pass through matter and don't interact with anything, an X-ray photon can interact with the whole atom, a single electron orbiting the shell of an atom, or even the nucleus. This will all depend on the energy of the X-ray photon.
In this video presentation, we discussed the 5 different kinds of interactions with matter: photoelectric, Compton, coherent, which is composed of Rayleigh and Thomson, pair production, and photodisintegration. We hope this helps you better understand the different kinds of interactions with X-ray and matter.